Section 3.6, Real-Life Applications and Problem Solving. This video will help you translate a written statement into a mathematical equation and translate and solve real-world problems using an equation. Algebra is a powerful tool when it comes to problem solving. Representing unknown quantities with variables allows us to organize and keep track of the information in a problem. Learning to problem solve with algebra requires a transition away from figuring out the operations that we need to use to solve a problem and focusing on setting up an equation that accurately represents the situation. Translate a written statement into an equation. So here's a table that will help you recognize keywords when we're translating written statements into mathematical equations. And so we have some words here that we're going to need to become familiar with for addition: the sum, add, total, plus, more than, increase by, deposit, greater than. All those words mean addition. Subtraction, difference, subtract, minus, less, fewer than, less than, decrease by, loss of, or withdrawal. Multiplication, product, times, of, not always, but often that of will mean multiplication, doubled, tripled, and multiplied by. Division, the quotient, divided by, divided into, goes into, per, this one comes up a lot when we're talking about like miles per gallon and things like that. Ratio, those all mean division. And then equality as our equal sign is equals, is, was, results in, is the same as, gives, and amounts to. Now let's take a look at an example that will help us understand how to translate a written statement into a mathematical equation. So example 1, the sum of 5 and 3 times an unknown number is 59 decreased by the unknown number. Find the number. Now that's way too much stuff going on there at once to translate it. So what we want to do is we want to break this down into little phrases. The first thing we want to do is we want to identify what our variable is going to represent. And we can pick any variable we want to, but usually people pick x or n. And then we want to let n, or x in this case, which I've chosen, equal the unknown thing in the problem. So let's go look back and look at the unknown thing here. Let's see, we're reading along and then we say, oh, it's this unknown number. So that's kind of a real simple thing, and it's kind of like right there in your face. Unknown number, yes, that's our unknown thing. A lot of times it'll be a little harder to find, but here was pretty easy. So that's our unknown number. And we want to write this down because when we get done solving for x, we want to know what x is going to represent in the problem. Okay? Once I have the variable statement now, I know what my x is going to be, my unknown number. Now I want to go back and translate this sentence here in phrase by phrase. So the first thing is this, is that we go, okay, the sum of 5 and 3 times an unknown number. That's the first thing that I want to translate. Let's see. The sum of 5 and 3 times an unknown number. So the sum means we're going to be adding. So I'm going to go ahead and write the addition sign down. What are we going to be adding here? 5 and, so I'm going to be adding 5. The 5 and 3 times the unknown number. Well, that's just going to be 3x because x is our unknown number. So let's read this back here. The sum of 5 and 3 times an unknown number. It's often a lot easier to read the math statement back and translate it back into words to check it. Okay? Is, that's our equal sign, 59 decreased by the unknown number. Well, decreased means subtraction, and decreased by the unknown number. So now we've got our equation. Now I want to go ahead and solve this equation. Looks like I have variable terms on both sides, so I'm going to get rid of the smaller one by adding x to both sides. So 5 plus 4x equals 59. Subtract 5. 4x equals 54. Divide by 4. Come over here and let's see. X is going to equal 4 is going to go into 54. 10. I don't think it's going to go in there very evenly. So let's see. Let's divide this out. 4 into 54. 4 goes into 5 once. Subtract, we get 1. Bring down the 4. 4 is going to go into 14 twice. No. 4 is going to go into 14 3 times, which is 12. So we get a remainder of 2. So it looks like we're going to get 4 and 2/4, which is the same as 4 1/2. Now, we could have also left this problem as an improper fraction. We'd have had to simplify 54 over 4 by cutting those in half, and that would have given us 27 over 2. So either of these two answers would have been correct on that. All right, let's go ahead and pause your video player now and answer practice question 2. When you're done, hit play to see how you did. And make sure you don't forget to write your variable statement here. Declare what your variable is going to represent. Okay, let's take a look. So here we don't know what a number is. That's what we're looking for, is this number. So let's go ahead and I'll choose n this time. You may have chosen x, but that's fine, or any other variable. Doesn't matter. So x is going to be that number. Once we say that n or x is going to be this number, now we're ready to translate. So a number increased by 12, all right? So our number increased by 12 is 4 times the number. So your equation should look like that. Once we get here now, we want to solve it. So we'll get variable terms to both sides. Sorry, variable terms to one side. Then divide by 3. So you should come up with n is equal to 4. All right, go ahead and pause your video player again and answer these 2 practice questions. When you're done, you can hit play to see how you did. All right, let's see. I'll choose x this time. And what's our unknown thing this time? 3 times the sum of 5 and a number. So there is my unknown thing. We're looking for this mystery number here. All right, now I'm ready to translate. 3 times the sum. Well, this is a little tricky. I want to take 3, but not times just one thing. I want to take it times the sum. So that's what that looks like. 3 times sum. We got to make sure we put that sum in parentheses so that we take 3 times the whole sum, not just part of it. Okay, so now let's see. The sum of 5 and a number. So here's the sum of 5 and a number is 48. All right, once I've got it written out here, I'm going to simplify this left side by distributing the 3. Subtract 15. Looks like 35. So 3x is equal to 35. Divide both sides by 3. And I don't think that's going to simplify. I think we're going to have 35 thirds. Or if we divided that out, let's see, 33. So that would go in there 11 times with 2 left over. So 11 and 2/3. Either of those answers would have been fine. All right, practice question 4. Let's figure out what the variable is. And again, it's that number in this case, or a number. Either one of those would have been fine. So I'll choose x and I'll say that's equal to a number. All right. So 5 more than, here's how we take 5 more than something. We add 5 to it. 5 more than 4 times a number. So here's 4 times a number is equals that number. Well, that's the same number increased by 35. Okay. Now I would subtract x from both sides to get the variables to one side. Whoops. So let's see, 5 plus 3x equals 35. Come over here to finish. So then minus 5. X equals 30. Divide by 3. X is equal to 10. Translate and solve real-world problems. To translate a real-world situation into an equation, we will need a variable or variables, the known quantities, and an equal sign. So since we're talking about an equation here, we definitely want to have an equal sign. So the key to translating is understanding what is going on in the problem and then figuring out how the items in the problem are going to come up to be equal. All right, so every time we write an equation, we know things are going to be equal. So you want to think about what's going on in the problem and how you can set it up so that the two sides of your equation will be equal. Often, when an equation has 2 variables, one will be an input variable and the other will be an output variable. So let's look at those definitions. The input variable represents the independent or starting values that kind of get placed into the equation. The output variables represents the dependent ending values that result from each of the input values. An equation with two variables is often called a function. And you can think of a function as a machine. You take this input value, you plug it into this function, which is an equation, do some calculations in the function, and then you get out of that the corresponding output values. Let's take a look at an example now that will help you understand, all of these definitions, a function, an input, and an output variable. Example 5. A taxi cab company charges $2.15 plus $2.35 per mile. First thing we're asked to do here is fill in the chart about the cost of the trip. So here we have them traveling 1 mile in the cab, and we want to know the cost of that trip. So to do that, basically, we're just going to take $2.15 plus $2.35. Notice, right when you get in the cab, you get charged $2.15 no matter what, and then every mile after you drive that, you get charged $2.35. So we'd add that up. And we'll get $4.50. So 4.5. So we come over here in this first stop, we put our dollar sign, and say $4.50. Now, to that, if we drive a second mile, we're going to get charged another $2.35. So all we have to do now is take $4.50 plus $2.35, and that's going to give us $6.85. We'll put our dollar sign on there, and then we take $6.85 plus another $2.35 for the next mile. It gives us $9.20. Okay, so basically what happens is on the very first part of the cab ride we get charged $2.15 plus $2.35. Then after that, every mile we get charged another $2.35. Question B, identify which of the values in the chart are the input values and then which ones are the output values. So what's happening here is the miles that we're traveling in the cab are our input values. Notice when I put a 1 in here, 1 mile, I get a cost out of this equation that I'm essentially or eventually going to set up here. And then when I put 2 in, I get this price out. 3 miles in, I get this price out. So my input values are the miles in the cab. So 1, 2, 3, and we'll go ... because there could be a lot of input values there. And the output values here are the cost of the cab ride. So $4.50, $6.85, $9.20, and that pattern would continue on as the same as the input values. Now we want to, in question C, we want to write an equation that represents the cost of the miles for the miles traveled in this cab. And we're going to let C represent the cost and M represent the miles traveled. So we know we have to have an equation here, and we know we want to come up with a cost of the trip. That's what we're kind of getting out of this thing is the cost of the trip. So I'm going to put my C right here, and I'm going to start thinking about how the cost of this cab ride is figured. Well, the first thing that happens is I get charged this $2.15 as soon as I step into the cab. And that $2.15 never happens again. It just happens one time. So I'm going to write $2.15. That's right when I walk into the cab or sit down. Now, next thing that happens is I get charged $2.35 per mile. Notice if I drive 1 mile, I'll get charged $2.35. 2 miles, I'll get charged that amount twice. 3 times that amount. 4 times that amount. So you can see here what we're doing is we're taking $2.35 and multiplying it times the number of miles we travel. Well, the number of miles we travel, we're going to let that be our variable M. So here is our equation for the cost of the cab. The cost of the cab equals $2.15 right when you sit down plus $2.35 times the number of miles that we travel. All right, question D. Use the equation to determine the cost of a 23-mile cab ride. Well, all we have to do is take 23 miles and put it up in there for M in our equation, and we'll figure out the cost of that cab ride. So let's see, cost is going to equal $2.15 plus $2.35 I'm substituting for a variable, so I'll put that in parentheses. Okay, so to solve this, all I'm going to do is take 235 times 23, and that gives me 54.05 plus I'm going to add the $2.15 that I got charged when I initially sat in the cab. And so this cab ride is going to cost $56.20. Go ahead now and pause your video player and answer practice question 6. When you're done, hit play to see how you did. Question 6. In Michigan, the sales tax on retail items is 6%, which is 0.06 as a decimal. So let's fill in the chart. So the retail price, and here's the tax charge. So if I'm buying something for $10, the tax charge is just going to be 10 times this 0.06. So if I take 10 times 0.06, I'm going to get 60 cents. Let's put a dollar sign out front since we're talking about money. All right, $15. I'm going to get charged 90 cents. $20, well, notice the pattern here. I just keep adding 30 cents every time I go up by $5 over here. So this is just going to add another 30 cents to that, which is going to give me $1.20. So identify which of the values in the chart are input values and which ones are output values. Well, my input values are the cost of the retail items. So that's $10, $15, and $20. Let's put some dollar signs on there. The output is the tax that we're going to get charged. So that's going to be 60 cents, 90 cents, and $1.20. And that pattern would continue as we raised the price of these input values that we're plugging into this equation. All right. Question C, write an equation that represents the sales tax charged on retail items in Michigan. Let T represent the tax charged and let X represent the retail price of the item. Okay, so T is going to be the tax charged. So to figure out how much tax we're going to charge, what we do is we take this 0.06 and we multiply it times the price of the thing that we're buying. And so X is going to represent the retail price of the item. And so X is going to go right there, and that's our equation. All we have to do is take the price of the item, multiply it by 0.06, and that will tell us how much tax is being charged. Question D, use the equation to determine the tax charged on a $545.60 dresser. Well, all right. So the tax charge is going to be just this, 0.06. I'm going to substitute this value in and multiply it out. Okay, so this is what I got for my decimal answer, 32736. Now, since we're talking about money, we're going to round this tax charge to the nearest cent, which is our hundredths place, which is right here. So I want to round it to the hundredths place, and the 6 is going to tell me to round that 3 up. So we're actually, and we're going to get an approximation here, but this is what we need since we're dealing with money, $32.74 is the answer that we should come up with there. Since we're working with money, we want to round the tax off to the nearest cent. All right, go ahead and pause your video player again and answer practice question 7. When you're done, hit play to see how you did. Question 7. In Indiana, the sales tax on retail items is 7%. Let's fill in the chart. So 7% tax, that's going to give us 0.07 as a decimal. All right. So we're going to take $10 times 0.07. And all we're going to do when we multiply by 10 is move the decimal place one spot. So if I take 10 times 0.07, it's just going to move the decimal one spot to the left. So we're going to get charged there 70 cents. Now then the total cost then would be $10.70. All right, question 2. $15 times 0.7 is going to give us So we're going to take $15 times 0.07, and that's going to give us $1.05. So to get the total cost, I'm going to take that $1.05 and add it to 15 to get a total price then of $16.05. Okay, $20, we'll take 20 times 0.07, and that should give us $1.40. And when I add that to 20, that's going to give me $21.40. And I should put dollar signs on all of these since we're working with money. Okay. Part B now, identify which of the values are the input values and the output values. All right, well, I think here, there's a couple ways of looking at this. For sure, our input values are going to be the price of the item. So 10, 15, and 20. Output values, you could have answered two ways here for the output values. You could have either chosen the tax charged or the total cost. I'm thinking since we kind of ended this one with the total cost, that would be a good place to have as our output values. There's nothing wrong with saying that the tax charge would be an output value, but since we kind of did two computations here and we kind of ended with the total cost, I think it would be more appropriate to put those values as our output values. All right. So part C now, write an equation that represents the total cost charged on retail items in Indiana. So notice we're not just getting the tax charge, we want the total cost charged here. So C is going to represent the total cost, and X is going to be the price of the item. So basically if we plug the price of an item into our equation, the equation should give us then our total cost. All right, well, let's start up again here and think about how we get our total cost. How does that come about? And you can see how we did it. We did it right up here in our chart. When I was getting the total cost for $10, I took 10 times 0.07 to get the tax on that. Then I added that back to 10. So X is going to be the price of the item. So that was kind of what 10 was. So basically what happens is I took, X times 0.07. That would tell me the tax that gets charged on X. And then I would add to that the value of X. Again, so if this was $10, notice I would take $10 times 0.07, get that answer, then take that answer and add it back to the $10. And you can see how we get an equation that looks like this. Now, typically when I write a number times a variable, I usually write that number out front. So I'm going to rewrite my equation just a little bit here, just so it's kind of in the normal form that we would see it. All right, so we'd have this 0.07x plus x. Now, if you really wanted to get fancy, you don't have to do this. This is a fine answer right here, but these are like terms. This is a 1x, this is a 0.07x, so you could have simplified this equation right down to this. And some people do use an equation like that to calculate tax. 1.07 times the charge on the price of the item. So either of these equations would have been fine. Okay, question D, use the equation to determine the total cost for a $347.20 table. Since most of you probably use this equation, that's the one that I will use here to calculate this. And I'm going to come up here where I have a little bit of room on the side to do this. So let's see. Total cost is what we're looking for. And we know they got 0.07 times now 347.20 plus 347.20 again. So I'm going to take 0.07 times 347.2. That gives me $24.30. And then I'm going to add that to the price of the item, 347.2. And that's going to give me then a total cost of $371.04.